I am recording. All right, so it is what, beginning of week 3. Last week, we didn't meet a week ago because it was Labor Day. So we're in Unit 4, Lab 4. So what's due today is the 13th. I didn't make everything. I usually give you a week, and we didn't meet last week, Monday, so nothing is due today. The coin flipping simulation with statistics, that's due, nominally due to keep you on track on Wednesday. This lab for in the spring was a stumbling block for some people. Some people don't like statistics. And so one thing is, if you're having trouble with 3, don't assume that means you can't move on to 4, if you can. But if you are having trouble with 3, ask, and don't assume it's something that you can do, you know, in 5 minutes the night before the test or something. I added, so this is the recording from last week. There's the lab, and then I added in, when I was interacting with Mark, I added this image that I saw off the internet for, this is here talking about a median, and how you get the median depends on whether you have an odd number of things or an even number of things. And then, but one thing here changes, and that's because when you, this is in probably, what is that? Java, maybe. When you divide in Java by 2, you get an integer, but when you divide by 2, when you do /2 in Python, it gives you a float or a double or something that's not an integer anyway. So this is the logic of it, but it's still not quite enough to get you there. And so then I also posted this little program, so I'll show it to you because I didn't show it to you before. Computer had to open with, try. All right, I have not trained this computer yet to open Pythons in Visual Studio Code. Let me open Visual Studio Code. There, out. Junk. Okay. And what this little program does is shows you, I just make n of 4 and I divide 4 by 2, and it's not 2, but 2.0, and it shows you that the type is a float. But if I do n / 2, that is 2 without any decimal part, and it's an int. So to get integer division in Python, it's 2 slashes. And as I pointed out, and where that comes in is I said, in the median logic, you are taking the length of the array and dividing it by 2, and we need that to be an integer. So we need an integer division, not a normal division where you get a float, but in Python, but an integer division. So we need //. Okay, so that is a little more hints to get you to the answer to lab 3. All right, any questions before I start the new stuff for lab 4? What? You, by lab 3, which is, you should be sending me for sure code. The first couple of times I was letting you send me screen captures. By now you should be sending me code. The code should be zipped up. If you are sending me a number of files, like today, you're going to have a file that reads another file. If you're sending me the file and the file then it reads, then those files should be in a single zip. Somebody yesterday was sending me individual things individually zipped, and I'm like, please don't do that. Everything in just one zip. All right. I posted a homework 2 videos, summarize them. 4 sentences convince me. You don't have to mention everything they mentioned in the videos, but talk, 4 or 5 sentences to convince me you watched them. You email me everything. I still have some people who are new to me who are like looking for where they post in Canvas their work, and you don't post in Canvas your work. That's why you can't find it. You just email me things. Okay, so new stuff. So last week, the program was that we were working with functions, and in the end, we worked our way up to a function, a statistics function that returned a dictionary. And now I want to use that in other programs. So it was a fairly generic thing. That's the one thing about a function, is that you sometimes design functions. Sometimes it just helps you organize, and other times it can help you. What you want to do is reuse it. And so if you want to reuse that, so if I write that statistics code and I like it, then how do I use it in other programs without just copying and pasting it into other programs? And that is by using it as a module. So that's our next idea here. Okay, so that should be available over here. So now there are 2 files. The one is the module, and then the other one uses the module. So here's the module, and this should look familiar to you. It's just our definition of our stats function that we had the other week. So this is just some comment, then it's def stats, that's the name of my function. I am working with this weird star args thing. So we talked about that last week. If you use a star in the definition and you have something that's already iterable, like a list, then you also call it with a star. So I'm using that approach. I start here, declare an empty dictionary, and then I start calculating my statistics. I calculated the average, and I set up a key value pair for the average. The key is mean, and then some number I calculated for the average to be the value. Figured out the standard deviation, set up that key value pair. Cast args. When args comes over and that little star in front of it turns it into a tuple. And then I wanted to order the list to get the minimum. And so then here I am sort of taking my tuple and making it a list, and then I can sort my list and grab the first thing, and that's the minimum. And so again, I set up a key value pair, and then I send back my dictionary. So that's complete review of that function. So we did that. I just went over it fast because we did it Wednesday and I forgot to record, but then I made videos from what I forgot to record last week, so they're posted on YouTube. All right. So that is just the definition. That function is not called in this file. It's just a file, a Python file with a definition, no more. Here I'm going to have what I'm going to call the driving program, the program that uses that function. And so here I am importing my module. So they're in the same location, they're in the same folder. I have to work harder if that's not the case, but that was the case for me here. And so here is the name of the file, my_stat_module. And then over here, I'm going to call it stat_mod. So that's the name I'm going to, once I bring it in, this is the name by which I'm going to refer to it. So now I have access to that function that I defined over in my module. So I make a list of scores. I am going to access that function. Here's the module, stat_mod, and then I'm going to use the stats function that was part of that, and I'm going to act on my scores. I use the definition with the star, so I use the call with the star, and then here's me printing out the results of my statistics as a dictionary, and then here's me printing out one of the specific values associated with the key of mean. So the new thing, this is just the end of Wednesday, the last thing I showed you Wednesday, but now broken into a module, a definition, a file with just the definition, and importing it. And now we're doing functions, but then a little bit later, we're going to have objects, and we'll treat the objects in a similar way. We'll have a file where we define the object, and then we'll have other files where we're going to use the object that we made. But here, so this is our scheme for bringing in a module. Any questions? Now, so the next thing is that Python has lots and lots of modules. There's already a statistics module that's way better than the little doodah one that I just showed you. That purpose was for me to show you, to give you some example of how to write your own module, how to write your own function, and how to make your own function a module. But there's a more elaborate statistics module that already exists. And I'm going to show you now how to bring in these sort of existing modules. And so that's here, some standard modules. Okay, so that's now open. Some standard modules, here we go. So there's a module called sys for system, and you can get the system's path, what's called the byte order, the platform. So things about how the architecture of like the computer you're working on, how it, this is going to tell me that it's like a Windows system, and this is going to tell me whether it uses little endian or big endian, if you know what that means. And path, I love paths. You all know that I love paths. There's a math library, so I can calculate factorial. So I never get to tell you to make you write your own factorial because there's a math library with factorial. And it also has log base 2 and all sorts of things, but so there's a math library. Import it and then use it. So you import it, then it has a name, and then you can use the things that are part of it. And the standard ones have documentation that you can sort of look up. There was a date time module. Date times are always very complicated, but so I'm just printing that I'm working with the date time module now. I can work specifically with the date, just the date, and grab today, or I can grab the day and time and do today, which will tell me the hours and the minutes and the milliseconds and all sorts of stuff. And I can ask what type of thing it is. It's going to tell me it's a date time thing. DIR is going to show me sort of all like the list of properties that it has. So that's a useful thing if you're working with some kind of module. One thing is if you're working with this kind of module, there's documentation. But if you're working with some other module and you don't know what the documentation is, this DIR little method here will give you a big list of things. And then we're going to look at the weekday. And it's not going to tell me Monday. It's going to give me some index that I would use to sort of, it depends which day you think the week starts on. Do you think the week starts on Sunday, then Monday is a 1. If you think the week starts on Monday, then Monday will be a 0, because computer scientists like to start at 0. So system, we did system. Now let's do operating system. So I can figure out CWD is the current working directory. That will tell me where. So when I'm running this program, it's thinking of it being run in a terminal, and that terminal is located. There's the code for the terminal, but then the terminal thinks of itself as having a location in your computer. So this will tell us where that is. This will tell me who's logged on. This is going to tell me the file will be the file that's running, and this will tell me its path. And then I can use that. I can get just the directory name. So the path will probably include the file name. If I say the directory name, it is going to peel off the file name. And then here I am changing the directory. So I can run, Python can run, if you've ever worked at a terminal and changed directories and such, Python can do those sort of things. So Python is your operating Python sort of in a terminal, and then you can do the sort of things that you would do at that terminal in addition to Python. So I can change my directory, and then I'm going to get the current working directory and show that it changed. I'm going to make a new directory. Again, that's a thing, that's a command that I can run. I can make a new directory. And of course, I called it poop. And then I can show you, I didn't move into that directory. I'm still in the directory that my file was in. And then I'm showing you the list of files there, and you'll be able to see that file and the new folder I made called poop. And one more module for fun. There's a web browser, and I'm using the web browser module to open a web browser to my page. So this should be fun. So let's So here we go, all sorts of stuff. What fun stuff do we have here? So I ran the program. Here's the system module. Here's the path. It's, I said, is it little endian or big endian? It's little. What's my platform? Win32. 6 factorial was 720. The log base 2 of 26 was 4.7, yada, yada, yada. Here I'm in the date module. Today's September 19th, 2021. If I do the date and time, I get more stuff. The type of the date is a date time. Here's all the stuff that comes with a date time. And then this was my, what's the weekday? And the weekday is 0. So it thinks Monday is the first day of the week. Yeah, here's my operating system module. I said, where am I? I'm in downloads. Who's logged on Blum? Where is my current file? Download some standard modules, F21, some standard modules, and then I just grabbed the directory. So I got rid of the Python file and just have the directory. Then I am, this was my working directory. This is where the file's located. This is me changing the directory from downloads to where I just was. And then I had created a folder called poop. And so now it's telling me that I have that file and poop. So where am I? Downloads, some standard modules. There's my poop folder. If I run this again, I'm going to get an error message that says you already have a poop folder. Okay. And what else? Oh, a browser should have opened up. There it is. So that browser was not open. They opened it, the default. They opened it up in IE or Edge or whatever the hell this thing is called now. So that was, and that's where I told it to. So it opened it. That's the default browsers of these machines. I didn't tell. That's what IT sets it up as. I didn't change it, but that's what Windows sets it up as, and we didn't change it. And but that's the page I told it to open to. Okay. Questions. So that is, so yes. How like overwrite a folder. Like if the folder had stuff in it and I wanted to clear it out, I'd probably write the code to remove a folder. And you've got to worry with a folder whether you have stuff in it or not. So I probably have to write the code that says empty it out and then remove the folder, or alternatively, I'd have to give myself that sort of slightly more permissions to say delete it even if it's got stuff in it. I'd have to like look up that. So if you really want to know, remind me of that question and I'll look up that code. It's probably in the module. We probably just have to dig for it. And there's probably a way to just sort of say, here's my command I know to run. And there's probably a way in Python, again, I need to look it up, but there's probably a way in Python to say, run this command. So it's like, I already know the command in regular command line stuff. Here, I'm just showing you that it also exists in Python, but I think there's a way in Python to just say, here's my command. I know it in regular old PowerShell or commands or whatever, and just run it for me. Sort of pretend you're a terminal user and do it. if I need admin privileges, I'd probably have to do that. I could probably do that in Python. Python's very powerful. Anything else? So, but I probably have to do some digging. So I will do some digging if you want and find it. All right. What is next? So that is that's using our function and using it as a module. Then there's some standard modules. Now I'm going to use one of the modules, the operating system module, just to get myself to make sure I'm located in the right place. And then I'm going to read a file. And so that's the next. That's what's next. Okay, so we're reading the file. Here's read file. And let me clear this. So I'm reading a file. The file is going to be, I'm going to call it a local file. The file is, they were just in the same, it's not, we're not coop anymore, we're read file. And I forgot to include the file you're reading. Damn, sorry, I zipped up the wrong thing. So I'm going to grab the file. Sorry. Where's my, let's just make it. Okay, so it's supposed to be Robert Frost poem. The one about the woods. What the hell is that? All right, so let me just make it. Frost poem. Woods in a snowy evening. There we go. Okay. Poetry. Whose woods? Yeah, let's do this. Blah, 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 blah. Okay. Notepad++. Paste. There we are. We have a text file. And I'm going to save it. And what was it called? Frostpoem.txt. I'm going to save as. I'm putting it in downloads. I'm putting it in read file. I'm calling it, lost it again, frostpoem.txt, frostpoem.txt. Okay. Check again. Okay, so there is, I need to fix that. There's the frost poem and the read file pie, and they're in the same location. Okay. So the poem is, there's the poem. Okay. There were some blank lines, if you'll notice, that will come up at some point. All right, so I'm going to run this program. And I read the poem 4 times and did different things to it different times. So here's just the poem sort of read in and spit right back out. That's the first time. The second time, I'm reading it in a slightly different version, and I put it all in caps. In this one, I put the lines of the program in a random order. So this is all the lines of the poem, but they're all rearranged. And in the last one, I kind of numbered the lines, and I got rid of the blanks. Okay. And there's some weird symbol in the only other sounds the sweep. So that's probably some kind of weird curly apostrophe. And that's why that's coming out weird. Okay. So let's see how to read a file. Okay. First thing I did was not reading the file, but using the operating system module to make sure that my terminal is located where my file is. So I'm finding the operating system will tell me where the file is, which is this file, the read file.py. I'm getting its directory name. So I'm finding out all of its C:\download / read file, but I'm getting rid of the file name here. And then I'm changing the directory to that location. So now my terminal, I don't know if I can show you that. My terminal started in downloads. And it's still in downloads, but in some part of the program, I was in the folder, at least while the program was running, at some stage, I was in that folder where the file is. Okay. Here's me opening the Frost poem for reading. And then here's me reading the entire poem all at once. And then I closed this F. So I opened up a stream to read. So a stream is like for you to send a bunch of consecutive data. So I'm opening a stream, and I'm opening it up specifically like, a file, a stream for reading text. And then I read everything that was in the stream, and I closed the stream. And then I printed the whole poem. And then I printed a line to separate. So here, when you're opening, you must remember to close the stream, or you'll end up with lots of resources that were opened and not closed, and that is going to use up resources in your computer. And if you do that too much, then it's going to be sort of like a memory leak situation where you have all these connections to resources open and not closed, and you're just being a pig about using resources. Okay. In version 2 of reading the file, we start with the keyword with, and then so with the file open and called F2, then I'm reading the file. And then if I leave the indenting, if I leave the with, it closes for me. So the with, I say I'm opening a resource, and so while everything that I want to do while the resource is open, I indent, and it belongs to the with. And when I close the with, there's an implied close. Okay, and then here is, I use the upper, so I put all that poem now in uppercase. I'm doing something random, so I brought in random. I'm using the shuffle, and so that is this is the one version where I put the lines in random order. So I use the with, so I don't need the close because I have the with. I'm opening that file yet again, and the stream I opened is F3, and now I'm reading the lines. And I'm not reading one line and waiting and doing something and reading another line. I'm reading all of the lines and making a list. So here I commented out, but I had print the type, and poem 3 was a list of lines of the poem. And then I can use random, has a method called shuffle, and that puts the lines in a random order. And then I wanted to look at, this is a way of looking at the last character. So poem 3 is, I had these lines of the poem. Poem 3:0 is just the first line after the shuffling. -1 is a way of saying the last letter. So if you put in these sort of negative indices, you sort of start at the end. And so this is the last character. So that's why I called it the last underscore car, the last character. And then here I am. Ord means get the number that corresponds to this. So get the ASCII that corresponds to that character. And now it's a number, but I want to display it. So then I have to cast it as a string. So that looks really cumbersome, but I have a character, get the ASCII for it, then get the string. Why don't I just print out the character? Because it happens to be a non-printable character. It came out to be a 10, and 10 is a line feed, not so you see the result of a line feed, but you don't see it as a character. You see it as a result of something that happened. It's more of an instruction than an actual character. Okay. But what I wanted to show you there, and we're going to take care of it in the next program, but when you read the lines, that thing that was putting you onto the next line is still there. So there are characters that put you on the next line. This can be a difference between Macs and PC files, that they end the lines differently. So if you ran this, if you made your own little file over in your Mac, God help you, then and did this, you might not find 10. I don't know what you'll find. I don't have a Mac. All right. This is me looping over that list of poem lines, which are now random, and I'm printing them out in lowercase. This end here is because each line of my poem, when I read the lines, still had that line feed character there. And so if I just said print line, print and then the line, I would get like an extra line of space in between all of them, because the line itself has that return character, and then the print statement has the return character built in. And so I'd be skipping a line between every time I printed a line of the poem. So here I'm dealing with it within the print statement. And in the next version of the program I'm going to show you, I'm going to get rid of it. I'm going to take it out of the line. So here I'm keeping it, but being careful about how I print. And then in the next version of the program I'm going to show you, I'm going to get rid of it. Okay. Last one. Thank God. Okay. Open up Frost Poem for reading. Call it F4. I am now going through the lines. Now I'm going through one by one. Before I read all the lines and made them an array. Now I'm more going through the lines in F4. I am stripping the line, and that is taking away blank lines and things like that. So strip is going to get rid of some white space for me. And strip, so this is more about the blank lines. So you see, oops, that's not what I wanted. In the last version, I had no blank lines. I still have the end of, I still have those characters on the end. I still need this end thing. So there's a strip, and then I'll show you in the next thing, there's an R strip. And that's going to fix our problem. Okay. Any questions reading a file? Just going to add to it. So if you add a question, ask it now. I'm going to add. I'm going to read a file and parse it. So I'm going to read comma separated variables file, a CSV file. Okay. Now this is a CSV. Let me. If I open it, it will open it up in Excel. It says pencils, pens, rulers, and this is the price of those items, and this is how many the person's ordering. But that's not what the file really looks like. If I open it, Notepad++, there it is. That's what the file really looks like. There's 3 lines, and there are commas between the things. And then here is order. Okay. So there's the file. I'm looking at it in Visual Studio Code. Here's the program that reads it. Here's my little get myself into the right location. I'm making lists for the items, a list for the prices, a list for the numbers. This is not where I want us to be when we're done this course. I don't want to work with parallel lists when we're done. I want to work with objects or something, but I haven't taught objects yet, so I'm just going to work for now in these parallel arrays or parallel lists. If you know already fancier stuff, then by all means go ahead and use it, but this is where we are right now officially in Python, so that's what I've got, so that's what I'm using. Here's my with, here's my open, here's my order CSV. I'm reading it, I'm calling the string F. I don't need to close F because I'm using the with. I'm going to figure out, I'm going to read it line by line. If there are any blank lines, I'm going to skip them. And I'm going to figure out what they ordered and figure out how much it costs. So sum is to add up, figure out how much they ordered. So let me just run the silly thing and you'll see what I'm talking about. They still have frost. Here it is. Your order was 150 pencils, 250 pens, 55 rulers. Pencils were 15 cents for a total of $22.50. Pens were 45 cents. Rulers were $1.45. The total was $214.75. And then here are my little lists. See my little list at the bottom. Okay. So I'm looping through the lines in the program. I am using the strip to see if there are any blank lines. If there are any blank lines, then when I strip them, this will be nothing and it will be false. I say, if I take the line and I strip everything out of it and there's nothing left, this will be false. But if there's anything left, it'll come in here. Then I'm going to take the line, I'm going to R strip it. I'm going to take stuff off the end. And that's going to be that weird little extra line feed thing. I'm going to split it. This is parsing. I'm going to split it on a comma, and that's going to produce 3 things. And I'm calling those things X. And so X0 was the name of the item. And so I appended it to my items list. The next thing was a price. X1 was a price. I cast it as a float, and then I appended to my prices list. And the third thing, X2, was the number of things they ordered. I'm casting as an integer and appending it to my numbers. And then I'm adding to my sum plus equal, and it started at 0. I'm taking the price times the number that they ordered and adding it all up. Here I am looping over the items, and I am printing out 4 things, a number I, and then I'm printing out the number they ordered, and then the item they ordered, and then the price they ordered, and then the multiplication. So I printed out a number, then just number 1, 2, 3, then the number of things they ordered, then the name of the thing they ordered, then the price of the thing they ordered, then the number they ordered times the price. Okay, so that was that great big long print statement here with all that formatting. So it was the counter, which I added 1 to, so it didn't start at 0. And then numbers I, that's how many they ordered. Items is the name of the item. Prices is the price for the item. And numbers times price is how much you're paying for that particular item within your order. This greater than 4 says that I'm using 4 places for the number of things they ordered, and I'm right justified. That greater than sign will tell me to right justify. That made these 150, 250, and 55 sort of line up. And then this less than 10 is for the words, and they are, so I'm saying use up to 10 spaces for the names of the items, and this time I'm saying left justify. So these numbers 150, 250, 55 were right justified, then these names of the items were left justified. Then I have, this is the price of an item. I used F as 4.2F. That says use 4 spaces altogether and 2 of them for the decimal place. And then the last one, I have a greater than 7.2. So for the price of the item within the order, use up to 7 places to display it. I am right justifying it because of my greater than, and I'm using 2 decimal places. So again, that got these over here to sort of line up on the decimal points. And then I printed the sum, and then I just printed all the little arrays. So read a file, parse a file, do something with the file. That's what you have to do. So what do you have to do? You're not doing a calculation, you'll be glad, but then you're writing some kind of complicated if statement. So then you won't be happy. So there's some little survey. I took it this morning. I think I wrote this in the spring. I think they took out one of the questions, but I'm not going to redo my thing. So there are these yes, no questions. The yes, no questions are in this COVID questions.txt. You don't have to do anything with the questions. You don't care what the questions were. But the results of the survey, so as people take the survey, we're putting the results here. I'm going to look at it in Notepad++. So there I am, and I answered the question. I'm coming to campus, and no, I didn't go anywhere near anybody with COVID. So I'm all right. And then here was McCooey. This was the spring. She wasn't coming in. But here was the Smith person, and they said they were coming in the first question, but then they answered one of the COVID questions, yes. And so we've got to tell Smith that he or she should not come to campus. So we're looking to make a list of email addresses of people who shouldn't, so that we should give them a warning not to come to campus. So if your first answer is no, we don't care about you because you're not coming to campus anyway. But if your first question is yes, and any other question is yes, then we have to tell you not to come. So so you're going to read this file, parse it, and then work with the ones and zeros or true and false, however you want to do it, and figure out anybody whose first answer was first thing was a 1, and anything else, if anything else was a 1. So it's some kind of weird, if you're working with Boolean, some kind of and or combination, then make a list of people we should yell at. And if you look at the file, you can figure out who we should yell at: Smith and Jones and Chopin and Satie, and that was it. So there are a few people to yell at. Any questions for the recording? Okay, stop recording.